Hello and welcome to another physics video tutorial. In this video tutorial, we are going to look at worked examples in Form 1 in Chapter 4, which is pressure. And we shall start by looking at question number 2 on page 87 of your course book. So let's go directly to this question and see what it entails. And this is the question that we are going to look at. So let's go ahead and read it. We are told that a girl standing upright exerts a pressure of 13,600 newtons per meter squared on the floor. Given that the total area of contact of shoes and the floor is 0.0368 meters squared, determine the mass of the girl and the pressure she would exert on the floor if she stood on 1 foot. Now let's go straight to the calculations. So what have we been given in this question? We've been given the pressure that she exerts on the floor, and it's here. So we shall give it at the symbol P as usual. And the area of contact between her shoes and the floor is this much. And we shall give it the symbol A again as usual. Now we are required to calculate the mass of the girl, M. Now we ask ourselves, is there a relationship or a formula that connects pressure, area, and mass? Now the relationships that we've looked at do not have a direct connection between these three, but we can show that they are connected. So let's start by what we know. If we are given pressure and area, definitely we can work out the third quantity, which is force, because we know pressure is given by the equation force over area. And let's start by writing that first expression here, because it is the one which gives us the way out. So we know that pressure is given by the expression force over area. So we know the amount of pressure that the girl exerts on the floor. We know the area of contact between her shoes and the floor. Now, how much force does she exert on the floor? We can work it out because we know pressure and area. But before we do that, it immediately occurs to us that the force that she exerts on the floor is equal to her own weight. So instead of force, we will write weight. And of course divide by the area, the same area that we have here. Now the mention of the term weight brings to us the relationship between weight and mass. And this is where now we get a connection between these three equations: pressure, area, and mass. Now how does that come about? We know that weight of an object is given by the mass of the object times the gravitational field strength, and of course divide by the area. And this is the expression. Let me write it properly here. Pressure is equal to mass times the gravitational field strength over the area. This is the expression that gives us the relationship between mass, area, and pressure. Remember, that is where we started from, because when we look at the details that have been provided in the question, we do not see immediately a link between pressure, area, and mass. And many questions in physics usually take this form. When you look at the details given first time in the question, you don't see the relationship between them. So always start with that which occurs most obvious to you. For example, for us to be able to arrive at this relationship, I started in a very simple way. I asked myself, what have I been provided? I've been provided pressure and area. I ask myself, is there a link between pressure and area? And this is obvious because pressure is given as force over area. This is an equation which I would want you to remember automatically after studying the topic pressure. This is a fundamental equation in that topic. in the sense that pressure is defined as force over area. The moment I recall that, I ask myself, can I be able to calculate the force that the girl exerts on the floor? And definitely that is obvious, because the force that she exerts on the floor can be calculated because the pressure and the area are known. And then I went right ahead. The moment I mentioned this, the force she exerts on the floor, I ask myself this question: what brings about that force that she exerts on the floor? And from the studies on force, this is a topic that we have already done, you will remember that the force that an object exerts vertically downwards is equal to its own weight. So you can see these topics are connected because we've already studied types of forces. And one of the types of forces that objects always exert vertically downwards on any support is equal to their own weight. So let's go right ahead and see how now we can get this m, the mass. So there is need now to make m to be the subject of this expression. How do we go about that? We realize that I must get rid of g and a from this side of the expression. That is, take them to the other side. How do we do that? Again, this one is a fundamental skill that I'll want you to get. So I'll go step by step. One of the quantities that I want to get rid of from this side is area, and you can see it is a denominator. When you want to get rid of a denominator from one side of the equation, you always multiply by the same, but this time a numerator. Of course, you multiply by a over 1, because what you want to get rid of is a denominator. You multiply by the same quantity, but now you make it to be a numerator. Now what you do to the right hand side, you can see I've multiplied by a. I will also multiply by a the other side of the equal sign. And you can see that a and a will cancel out. The next quantity I want to get rid of is g, and you can see g is a numerator. So I must divide this expression by g in order to get rid of it. And again, what I do to the right hand side, I do to the left hand side. I divided by g, so I must divide by g over here. And again, you can see g and g cancel out, and I'm left with m. So m is definitely going to be equal to pressure times area, which gives me the weight of the object, of course, divided by g, and this will give me the mass. The pressure is 13,600 times the area of 0.0368, and all these I divide by the value of the gravitational field strength of the Earth is 10. Of course, if I use my calculator, I'll get the mass of the girl to be 50.048 kilograms. And that is the mass of the girl. Now, in part B, we are told that now she stands on 1 foot. This is like saying that the area has been halved. The area has been halved. There are two methods that we can use here. We can use this expression, the fact that pressure is inversely proportional to area. Pressure is a dependent variable. It depends on area. When we say that pressure is inversely proportional to area, we are saying if area is doubled, pressure will be halved. Similarly, if area is halved, like in this case the area is halved, pressure is doubled. And because you can see that we've been given the pressure as 13,600, we immediately know that the new pressure when the area is halved will be double. So it will be twice this value. 13,600, and we get 27,200 newtons per meter squared as the new pressure. The pressure has doubled because the area has been halved. The other method that we can use is very simple. If the area has been halved, we just divide this area by 2. And when you divide it by 2, we get the amount of force which the girl will exert on the ground, which in this case will be her own mass times g, and then you divide by that half area. And it will give you the same value of 27,600. Maybe you can try that and see whether it gives you this value. For more video tutorials, notes, and assignments, I invite you to join my online physics class. All you do is send me your email using the email address below.